Hello everyone. Now, yesterday, many of you people have missed the class, and yesterday I was not able to upload that video. I'm so sorry, but now I can provide you some of the concepts that we had already covered in the previous class. That is the concept about a centripetal force and the centrifugal force. What are the two forces? Suppose if I assume that there is an object who is rotating in a circular motion. Suppose in this direction it is rotating, right? So it should be tied with something. With the center actually, right? So there is a force which is always responsible for the motion. So that kind of force who is responsible for the circular motion, that kind of force is known as centripetal force. That centripetal force always works to the center, that means in inward direction, right? Here whatever we have just mentioned, that is the force is called the centripetal force, is a real force, right? One thing you should remember, that a centripetal force is a one kind of a real force, right? Centripetal force is a real force. It works in in the inward direction, right? It works in the inward direction, and it is responsible for a particle to move in a circular motion, right? Now what is the value of that force? Now, initially in the last class we had assumed that the acceleration, that is called the centripetal acceleration, the value of it, that is equals to v square by r. If the acceleration is having the value of like that, then for that case we can find out the force if the mass of that object, that is equals to m. If we assume that force equals to mass multiplied by acceleration, so we can find it out as mv square by r. So the expression we have just got, it can be changed in a different way. We know a relation between omega v and r. So what is the relation between omega v and r? We know that omega equals to v by r. I think you guys know. You had the relation as v equals to r omega, but we can write down that expression in that way also. So if I write down omega square, so that will be equals to v square by of r square. So but here one r is missing, so that's why I have to make that equation like that, m v square by r. We are just multiplying r in numerator as well as in denominator. So how the expression will look like, that is of m v square by r square multiplied by r. So here v square by r square can be written as omega square, so it will be written as m omega square r, right? So this is another formula of the centripetal force, right? The formula for centripetal force we have found, that is of m omega square r. So two formulas are there, m v square by r or m omega square r. Okay, so just note it down, the formulas. Next we had the concept about a centrifugal force. Centripetal force is a real force which is working in the inward direction to move the object in a circular motion. I hope it is clear. Now we will move for the centrifugal force. What is centrifugal force over here? Let me explain. I'm just saving this PDF for your future purpose. Then I will just move for the concept of centrifugal force. Okay, what is centrifugal force? Let's see. Suppose if an object is in circular motion, again I am taking that boring example, that an object is already in circular motion who is rotating in this direction, right? In this direction it is rotating. So only one force is not responsible, that we know that centripetal force is responsible for the circular motion, but when you are in circular motion, suppose if you have just traveled a giant wheel, I hope. So in the case of giant wheel, if you are in that giant wheel, that means you are in circular motion. If I just make that diagram of a small giant wheel, that can be found in village melas, right? Now in that giant wheel, if the giant wheel is rotating in this direction, and if you are in that giant wheel, then you are in circular motion. Suppose a person who is at the outside, who is just watching you, he can see that you are in circular motion. Now if you are in circular motion, you will feel a outward jerk, right? You will feel outward jerk, and you will feel that if the giant wheel breaks, I will be thrown off that circular path in this tangential direction, right? Whenever an object just leave the path of that circular motion, then it moves in the tangential direction, right? So every time you will feel that an outward force is working on you, and if the giant wheel breaks, you will be thrown outward of that circular path. So that kind of force, which is not a real force, that kind of force which is not a real force, is known as a centrifugal force. So let me write it down. Centrifugal force is not a real force. First point, is not a real force. That means it's a virtual force. If it is a virtual force, that means in this case you have seen that the centrifugal force is working on the outward direction. Whatever the object is in circular motion, on that object the force will work in the outward direction, that you will feel. Suppose you are traveling in a car, you are traveling in a bus, then whenever the bus or the vehicle just takes a sudden turn, you will feel an outward jerk in some direction. You will just align yourself, right? So that kind of force that you feel is a centrifugal force. It's not a real force, because we are just assuming that that kind of outward force can exist here. So it's a virtual force, right? The second thing, that it is outward in nature, and the magnitudes of centrifugal force is same as centripetal force, that is equals to mv square by r or m omega square r. In this case, if I just write down the value of centrifugal force, f of g, that is equals to mv square by r and m omega square r. But in that case, if you take that the direction of centripetal force is inwards, is in the direction towards the center, then in that case it is in outwards, right? So that means if the direction of that inward, if that inward direction is taken as positive, then that outward direction must be negative. So that's why the direction in this case will be negative. Okay, so this is the very basic concept of centripetal force and centrifugal force. I hope you have just got the difference also. What is the difference between these two forces, right? Next, we had moved about the banking of a road, right? Whatever the forces that are responsible when you are just taking a turn in a road. Let me just move to the next concept. I hope this concept is understandable to you people. If you don't understand any point, or if you are having some problem in understanding the expressions, or if you have any question, then just tell me. I can clarify that. Okay.